Okay, so I'm going to assume that you guys haven't dealt with probability problems probably in a while, since, middle, high school, maybe, or if you've done some studying already for the GMAT. But either way, the goal here is by the end of the hour, you'll have a better sense of what the fundamental concepts of this topic are, and how the test likes to test you on those concepts. And so they'll start easier, but they'll definitely get harder. And so the last couple we'll do are definitely not straightforward at all. So first of all, just what is probability? How do we define probability? All probability is either between 0 and 1, or between 0% and 100%. And it's essentially just a fraction of the likelihood. We've got some people not on mute, so do me a favor and mute yourself if you have background noise. But it's essentially defined as the number of ways that, if we're interested in the probability of X something happening, the way to calculate that would be how many ways could X happen divided by the total number of possible outcomes that within whatever we're talking about could ever possibly happen. So if there are like 100 things that could possibly happen, and 40 of them include this X thing happening, then we say the probability of X happening is 40%, 40 out of 100, 4/10, 0.4, anything like that. And a probability of 0 is the lowest possibility, or lowest probability number, which would be it definitely cannot happen. That's 0. And probability of 1 would mean it absolutely will happen. Nothing else can happen. It's just that's going to happen with 100% certainty. So all probabilities are between 0 and 1. There's no negative probabilities. There's no probabilities greater than 1. Okay. So if we look at a problem like this, here's one way they could test this. This is a problem that would show up on the data insights part of the exam. It's actually only part of a problem, because this problem actually has 2 like sub questions in it, but for our purposes, I just put this one question here. And so this is part of this like table analysis, or charts and graphs, basically. So they give you some charts and graphs and tables of data, and you basically have to read the table and then answer some questions about it. So in this case, well, take like a minute and just read that and see if you can come up with an answer. So here are the answer choices in parentheses. Take a minute, see what you can come up with there. All right, so just launch the poll. You just want to pick A, B, C, D, or E. Just first one being A, B, C, then not labeled letters, but you get the idea. And I'm going to close it in 3, 2, 1. All right, so of the people who answered, most people like answer choice D, which is the correct answer. A couple of people went for other answers, but does anybody who got that answer of 0.6 want to explain how they got there? So that's the right answer. I know we don't know each other. It's kind of awkward. Don't be shy.
Yeah, I mean, I can take over. This is Patrick. Can you
Hi,
hear me well?
Patrick.
Can you hear me well?
Yeah, I can hear you fine. So yeah, so talk me through this. Yeah, how did you approach this?
Yeah, actually, I looked up the numbers for all the scores that are below 40. So
All
this
right,
includes 0 to 9, 10 to 19, 20 to 29, and 30 to 39. So the overall number is 20. So we have a total score. The what is it, denominator for the formula that we saw on the earlier page is 20. And now
right. So there's 20 total scores that are less than 40,
yes,
right?
indeed.
Scores less than 40. Okay. And
Yeah.
then if we select one of those scores that are less than 40 at random, the probability the score is greater than 19. Yeah, so then
Yeah.
so keep going. So this
It's
is going to be our
five,
denominator.
five, five, 5 plus 7, so it's 12. And we have then 12 over 20. Yeah, we can do it by 12 over 20, which would be shortened to 3 over 5, or we can even go to 60 over 100, and this would give us 0.6, 60%, or whatever you want to call it then.
Exactly, right? So the total number of possible outcomes that are scores less than 40 is 20. Then the number of scores that are within that range but are greater than 19 is these guys between 20 to 29 and 30 to 39. There's 12 of those total. So 12 out of 20, which then reduces to 6 out of 10. Or if you want to do it as a decimal, 0.6 or 60%. Right. So the probability within that range of picking a score greater than 19 is 60%, 0.6. Okay. Nice job. So yeah, the issue here is I think maybe some people, you might have been thinking, oh, I got to take a probability out of the whole chart, right? Out of the whole 60 scores, right? But since it said if a score less than 40 is selected at random, that is defining the total outcomes that we have to look at. So we're not actually looking at all the test scores. We're only looking at the ones less than 40. And within that set, the probability of picking one greater than 18 is 12 of those 20, 60%. Okay. So that's just the only math you have to do here is just adding up, how many numbers in each bucket there are, but it's really just more about reading the chart carefully and reading the question carefully. But there's just a warm up of just like, that's a probability question. Stop me if you have any questions, but otherwise keep going. Okay, so let's talk about tossing a quarter. So, well, here, just do that. Just this is number one. So take like a minute. You can come up with an answer to that.
I'll have to do this for a bit. What is that? Just a GMAT class.
I opened the poll. Suen asked in the chat, can we see a recording on YouTube afterwards? I am recording this. I don't know where we host the recordings of the free live sessions. I don't know that we put them on YouTube. They're somewhere, but I'll double check that. But I'm sure you guys will be getting a follow-up email imagine it would be in there, but I'll double check with our tech team. Okay, everybody got this. This is 25%. Okay, this, you know, hopefully it's easy. But somebody explain, why is this 25%? How'd you get that? Oh, we are putting this up on YouTube? Oh, well, then I guess we're putting this one up on YouTube. Cool. I'll have to start my own YouTube channel. So anybody, well, I'm gonna start cold calling because guys all got this right, almost everybody. Oh, Long's experimenting with the writing. Yeah, I can scribe. I mean, if you guys want to scribe, I'm happy to, but you're welcome to rather. How about Tony? Any thoughts on this one? One half times one half is 1/4. Well, that's right. Okay. So 1/2 times 1/2 is 1/4, right? So the probability of getting ahead was 1/2. And then again, the probability of getting ahead on the second one is also a half. So the probability of getting this and getting that successively independent events, right? Like getting the first head doesn't affect the likelihood of getting second head. So they're independent events. So you just multiply them as 1/4. Okay, cool. That works. That's 25%. Any other ways to think about this? Or let me ask you this. What would the probability be of getting one head and one tail? Would that also be 1/4? Steele says, yeah, it'd be the same. So how about this? Can anybody, let's figure out how many total possible outcomes are there if we toss a coin twice? What could we get? We could get a head and a head. We could get a head and a tail. We could get a tail and a tail. Anything else we could get in order, right? So this is like first toss, second toss. First toss head, second toss head. First toss head, second toss tail. First toss tail, second toss tail. Yeah, what's the fourth possibility, Steele? I only got 3 here. Yeah, TH, tail and a head. Okay, so wait a second. So there's 4 total possible outcomes, right? Total possible outcomes. If we toss a coin twice, there's 4 possible outcomes. Now, if we wanted to say, okay, we're probably getting heads on both tosses. So head is 1/4, right? It's right there. But then so that's right, okay? But then I said, what if I instead asked, what's the probability that the quarter will land on 1 heads, 1 tails in any order? And some of you guys said, well, that's also 25%. So it's a half times a half, right? Well, let's look over here, right? There's still 4 total possible outcomes. But how many of them are 1 heads and 1 tails? 1/2. There's 2 total possible outcomes. Okay. So just be aware of this, right? It's not as simple as saying, okay, well, the probability of the first thing happening is that, and the probability of the second thing happening is also 1/2, and you just multiply them, right? If there's only one way for it to happen, like there's only one way to get heads. So it's just a half times a half. But we're going to get into trickier ones where we're going to have to account for there's different ways that we could get that number of heads or that number of tails. So if we had asked to get 1 heads and 1 tails in either order, you would have to account for both getting a heads first, then a tails, or getting a tails first, then a head. Okay. And so that's not 1/2 times 1/2. Well, it's 1/2 times 1/2 equals 1/4, but 2 of them, right? So the probability of each of these 4 outcomes is 1/4, right? The probability of this happening, 1/4, and this is 1/4, and this is 1/4, and this is 1/4. But if we were saying, well, what's the probability of getting one heads and one tails in any order, you'd have to add together that and that. Okay. So that's kind of where we're headed. So you have to, I want you to start thinking about accounting for the different orders in which things could happen. Okay. Stop me if you have any questions. All right, so let's try that. All right, so good. So everybody who's answered is getting it right, but not as many people have answered this one. So it's a little bit trickier. So I'm gonna close it there, but no, nice job actually. Great. 9 people agree that it's C. Anybody want to tell us why it is C? Why is this 3/8? I don't know who answered what, so I have to trust you. I'm either going to start cold calling people, and if you got it right, maybe you didn't. But Sierra, any thoughts? Sierra may. Oh, just your decision tree and counting. Oh, cool. Okay, dude. If you want to come off mute and talk us through that, because that's a good way to do it.
Yeah, so
Okay.
I basically split it up because the first toss will either be heads or tails.
Right. So we toss it once. It's either going to be a head or a tail.
And then from there, you just split everything off. Heads or tails again for toss 2, and then heads or tails again for toss 3. And then all I did was count up how many times there were exactly 2 heads. It seemed like the fastest way to do it, at least for me. I know there's like some mathematical thing that you can probably do, but this is what worked best.
This is a perfectly good way to do it, right? So let's just make sure everybody knows how to read this tree, right? So we toss the coin once, and then we either get a head or a tail. And then we toss it again. And now if we had gotten a head first, then we still could get a head or a tail, right? And then again, we toss it, and if we got a head and a head, then we get a head one more time, or we could do head, head, tail, or we could do head, tail, head, or we could do head, tail, tail, right? So each of these, there's 8 total possible outcomes, right? Because basically there's 8 total branches that end here. So it's like 1, 2, 3, 4, 5, 6, 7, 8 total possible outcomes. And of those 8 total outcomes, which is our denominator, how many of them have exactly 2 heads? Well, let's see. So head, head, tail. So this one does. And then head, tail, head. This one does. So head, right. So head, head, tail, head, tail, head. This is head, tail, tail. So that's not it. This is tail, head, head. There we go. tail, head, head. And then, yeah, those are the only three that have exactly two heads, and that implies that the third one has to be a tail. One of the other three has to be a tail. So that's 3. Right, so it's 3, 8. Cool. So yeah, sometimes it's just, just write them all out. You could also just literally write them out just without doing the actual decision tree, but just write out like, okay, I could do all heads, or I could do 2 heads and 1 tail, but then I have to account for the different orders in which that 1 tail could show up, right? So I literally just like start with the tail here, and then I move the tail to the left, and the tail to the left, and then that's it. And then I could also do all 3 tails, and then I could do 2 tails and 1 head, and then again I would just have to account for the different orders in which that could happen. And that's just another way of organizing. I got 8 total possible outcomes, and of those 8 total outcomes, 3 of them have what I'm looking for, which is exactly 2 heads and 1 tail. Irvin, mathematically, yeah. So for each of these outcomes, it's 1/2 times 1/2 times 1/2. Any of these 8 possible outcomes, like if I said, what's the probability of getting H, then getting T, that's 1/2 times 1/2 times 1/2, which is 1/8. But then there's 3 of them, right? There's PHTH and there's PTHH, right? So that's why it's 1/8 times 3. So yeah, a couple different ways to approach that. Okay. Any questions there? Let me know, but otherwise keep going. All right, so now we're getting into more times. 5 times. Try that. Okay, just relaunch the poll. Looks like 2 answers are more popular, but not getting as many answers. That's okay. What I'm doing. Yeah. All right, that's I'm gonna close it there. So I got 9 people answered. B is the most popular answer. Few people went for C, 1 person went for D. Okay, so I'm not gonna tell you the answer yet. Let's see if we can figure this out together. So whether you got to an answer or not, or if you're sure about your answer or not, let's see what we can figure out here. First of all, can anybody tell me what the number of total possible outcomes here is going to be? Meaning, if we're trying to figure out the probability we flip a coin 5 times. I don't think we're going to have time to write out all of the possibilities, right? But how many total possibilities are there? Patrick says 32. Yeah, where'd you get 32? Yeah, Irvin agrees. Yeah, Patrick, where'd you get 32 from?
I got 32 from 2 to the power of 5.
Exactly.
So because we are looking for 5 times, so 2 times 2 times 2 times 2 times 2.
Exactly, right? Because each time we flip a coin, one of two things could happen, and then one of the two things is going to happen, right? But if we're just counting up total possible outcomes, if we flip a coin, 2 things could happen. We flip a coin again, 2 things could happen again, 2 things could happen again, 2 things could happen again. So that happens 5 times. So the total possible number of outcomes is 32. Okay, let's just pause here. Are there any answer choices we can get rid of just by knowing that? Where is that 32 going to factor into our problem? Yeah, Prem says, well, how come we can get rid of these 2/5 and 3/5? Yeah, because they're not factors of 32, right? So if whatever our answer ultimately is going to be, the denominator is going to be, the fraction ultimately is going to be something out of 32, and maybe it'll be reduced down from that, right? But if we look at this, it's like 1 out of 32. Well, that at least could be a probability of something happening within the total possible outcomes of 32 possible outcomes of flipping a coin 5 times. Or maybe it's 5 outcomes out of 32. Or maybe it's 5 out of 16, which is the same as 10 out of 32, right? But then they're just reducing it down. But 16 is a factor of 32. But if you look at 2/5 and 3/5, 5 isn't a factor of 32. So there's no way for 2/5 to be something divided by 32, right? You can't reduce a fraction of a whole number fraction of 32, right? Like obviously the numerator and denominator will both have to be integers. You can't reduce that down to 2/5 or 3/5, right? There's no way for that to work. So there's no way that those are the right answers, okay? And sometimes just knowing that, so just knowing the total number of possible outcomes is enough to get us closer to the right answer, okay? All right, now, any volunteers want to talk us through how to figure out the number of outcomes that we're interested in terms of getting exactly 3 heads, 2 tails in any order? I mean, did anybody try? I don't know if we want to draw a whole decision tree, but did anybody just start writing out the possibilities? All right, so Irvin says, right, so the probability of any one happening is just 1 out of 32, right? So literally just getting head, 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 tail, tail. The probability of that is 1 out of 32, right? But that's not the only way to get exactly 3 heads and 2 tails in any order. So, Kristen, you're saying the same technique that Irvin did on the last example, which is what? So, and I'm just trying to read the chat here. So, Irvin, how are you getting to 10 ways out of 32? Because that's right. But how are you just getting straight to, oh, there's 10 ways for that to happen?
So I looked at the code of 3 heads and 2 tails.
Mhm.
There's 5 total letters, and then
Yes.
I divided that. Well, I did 5 factorial divided by the indistinguishable. So there's 3 heads, so that's 3 factorial, and then 2 tails, which is 2 factorial, and that comes out to 10.
Okay, so you know this formula already, which is
Yeah,
great.
yeah.
Okay, so let's come back to this in a second. Here, I'm just going to move this over here. So that's exactly right. But let's say you didn't know that one. We're going to come back to this. So, I mean, let's say we don't know that formula. Is there any other way we could figure this out? I mean, we could just start moving these things around. Let's just see. We could, okay, if we take these two T's, we could just move the T's over. So it could be HH, TT, H. It could be HTT, HH. It could be TTHH, H. Okay. We could split the T's up. So it could be like H, H, T, H, T, H, T, H, H, T, T, H, 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 T. Now check this out. We've already got to 1, 2, 3, 4, 5, 6, 7 ways. And I feel like we haven't even gotten all the way there. But how's that help us? We're already I've already come up with at least 7 ways, right? We know it's going to be out of something 32. Well, it's not this, and it's not this. It's got to be that. Okay. So some of these, sorry, my dog is freaking in. You know, use the answer choices to your advantage. Okay. Because even if you don't know the necessary formula, or you don't know exactly, you know, okay, I calculated all the possible different ways, that doesn't mean you can't get to the right answer. Right. So just by knowing the total number of possible ways is 32, that allows us to get rid of 2 answer choices. And then knowing that the number of ways for this thing to actually happen that we're interested in is more than 1 or 5 out of 32 ways. So there's only one possible answer. Okay. So strategically, you know, this is an important thing, particularly when you're dealing with probability. The other thing is, so this formula is basically the way to calculate the different orders that the letters could be in. Basically, it's a couple things. So type this. So there's n factorial ways to put n unique items in order. So like if I have 3 things, let's say I just have 3 items. Say I don't know color here. So let's say I have like 3 items, A, B, and C. Well, there's 3 items. And how many ways could I put those 3 items in order? Well, I could do A, B, C. I could do C, B. I could do B, A, C. I could do B, C, A. I could do C, A, B. Or I could do C, B, A. C, A, B, or C, B, A. Right? Okay. So that's 6. That's 3 times 2 times 1. So 3 factorial ways, which is 3 times 2 times 1 equals 6, to put 3 items in order. And the reason that formula works is, like, if I have 3 items and I got to put them in order in 3 slots, whichever letter I pick first, I've got 3, or if I've got my first slot, think of it this way, like I got my first position and I need to fill it, and there's 3 letters I could choose from to put in that first slot, and then whichever one I pick, let's say, right? Then I have only 2 letters left to put in, to choose from to put in the second slot, and that's it. And then for that last slot, I only got 1 left, so I'm forced to pick that last letter, right? So that's why this works. 3 times 2 times 1 to put 3 things in order. If I want to put 4 things in order, it's 4 times 3 times 2 times 5 things in order, 5 times 4 times 3 times. Okay, so that's the first thing. The other thing is, though, okay, what if some of the items aren't unique, right? So if I have 3 unique items, A and B and C, then if I move B and C around, that's a different arrangement, right? But let's say I have, here, I'll put this over, I'll put this here. All right, so let's say I have color. Let's say I have A and B and B. So it's 3 items, but 2 are the same, right? So instead of it being 3 unique items, A, B, and C, now it's A and B and B. So how many ways could you put those things in order? well, let's look. It's A, B, B, or it's B, A, B, or it's A, B, or no, we already did that. It's not A, B, B, or it's B, B, A. That's it. Okay. There's only 3 ways to do that, because now instead of having like B and C and B, it's just B and B. Okay. So the formula for that is n factorial over r factorial, where n is still the number of items, and then r is the number of items that are repeated, that are the same. Okay. So going back to HHHTT, if I want to know how many different orders I could get 3 heads and 2 tails, right? HTHTT or whatever it was, right? The shortcut here, which Urban already knows, is there's 5 letters, right? 5 total letters, but then 3 of them are the same. There's 3 H's, and then also 2 of them are the same. The 2 tails are the same. So the shortcut formula for this is 5 factorial over 3 factorial, 2 factorial, where it's n factorial over r factorial, and it could be another r factorial if there's another repeating item. For however many repeating items there are, you just basically divide that out in the denominator. So this is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So like that cancels out with that. And then that's 5 times 4 over 2. So I can like cancel out that. So that's 5 times 2. So that's 10 ways. Okay. So 10 out of 32, which reduces to 5/16. Okay. That's the shortcut to calculate. But I wanted to emphasize that you don't actually need to know that formula you could still have gotten it right without knowing that formula. Okay. But now you know the formula. Any questions? No? All right, keep going. All right, try that. All right. So about a dozen people got answers in, and almost everybody who answered got the same answer, which is E. So yeah, this one, sort of a trick to this one, but nice job. Hopefully the last one also sort of paired to this one. Steele, you want to just come off mute and tell everybody what you just direct messaged me? That's pretty much the trick.
Yeah, I didn't really have any math behind it. I just realized that there's only one example where the nickel would be flipped on heads every single time.
Right,
So the
so-
remaining answers
So if you do
are-
H, 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 there's only one way for that to happen. So what's the probability of that happening if you flip it 5 times?
1 in 32.
Right, so that's just 1 out of 32, right? One way out of 32 total possible ways. It was 1 out of 32, right? So that's the probability of getting all heads. But then how does that get us to the answer of probability of getting tails at least once? Still, keep explaining.
My bad. There's
okay.
31 remaining ways if you take away that one way that is all heads.
Right. Okay. So this is all. So rather than actually figuring out and calculating all the different permutations of, okay, I could get like 1 tail and 4 heads, or I get 2 tails and 3 heads, and a whole bunch of different orders that all these ways could happen. All you got to do is say, hold on. If I want to get the probability of getting tails at least once, right? So if you say probability tails at least once, right? Then the only other thing that could happen is getting no tails. And if, right, those are the only like possible things that could happen. You either get no tails or you get tails at least once. And so if you add those two things together, they should add up to 1. They should add up to all the total possibilities, the total probability. So like one of those things is going to happen, right? So if I want to calculate this, it's actually going to be easier to just calculate this and then subtract it from 1. And then I'll have my answer. Okay. So anytime you're doing a probability, it says what's the probability of something happening at least 1 time. What you want to do is calculate the probability of it happening not at all and subtract that from 1. So the probability of getting no tails is the same as the probability of getting all heads. And there's only one order for that to happen. There's just head, and then a head, and then a head, and then a head, and then a head. So that's 1 out of 32 total possibilities. So the answer to probability of tails at least once equals 1 minus 1 over 32, which then equals 31 out of 32. Okay, so that's fine. Also, this is a good one. Just think about, like, are there any answers you could knock out without doing anything? Before we even thought about doing the probability of all heads thing. Like, does it seem relatively likely or relatively unlikely that we would get tails at least 1 time when we flip a nickel 5 times? I mean, if I was like I'll bet you guys, $20 that, like, if I flip a coin 5 times, I bet you $20 I'll get tails at least once. Like, would you take that bet? If I'm betting that I'm going to get tails at least once at 5 times, like, I'm pretty sure I'm going to get tails at least once, right? So how does that help us? If the answer that we're looking for seems relatively likely, or even very likely, so how does that help us? Or does it help us at all? Do all 5 answer choices seem? Yeah, yeah. Ben, I don't know how to say it. Hussein, Ben. Yeah, I mean, the answer should be closer to 1, right? It should be a high probability. So like 27 out of 32. Yeah, that could 31 out of 32. Yeah, maybe. 9 out of 16, that's like a little more than 50%. I mean, I feel like it would be higher than that, but it's definitely not these first two, 1 out of 32 or 3 out of 16. There's no way. That's way, way too low, right? So the probability should be pretty high. So that allows you to get rid of at least 2 answers, if not 3. Okay. So again, use just kind of test of reasonableness. Bargov asked how to solve using n factorial over r factorial. Okay, so the way, well, first of all, I would never solve this that way. Okay. Anytime you see a thing of what's probability of something happening at least once, that means you want to solve it for probability of not happening at all and subtract that. Okay. Now, if you wanted to do it the other way, which again, I would not recommend, what you would have to do is figure out what's the probability of getting 1 tail and 4 heads, plus what's the probability of getting 2 tails and 3 heads, plus the probability of getting 3 tails and 2 heads, plus the probability of getting 4 tails and 1 head, plus the probability of getting 5 tails, 0 heads. Okay, and then for each of those, you could do the n factorial over r factorial thing, right? So like this would be 5 factorial over 1 factorial, 4 factorial. And this would be 5 factorial over 2 factorial, 3 factorial. It would be 5 factorial over 3 factorial, 2 factorial. 5 factorial over 4 factorial, 1 factorial. 5 factorial over 5 factorial. I get 0. Oh yeah, it's all 5 tail. All right. Notice, like these two are the same, and these two are the same, right? But you would still have to add these all up, and these would all add up to 31 total possible ways out of 32. Okay, but again, I would never recommend doing it that way. It's a much, much more efficient way to do it. There's probably no tails, which is just 1 out of 32, 1 minus 1 out of 32, 32. Okay. All right, let's try that. Yeah, that was about 2 minutes. Nope, nobody got to an answer. Oh, a couple people got it. Only a couple people. Okay. Yeah, I promised they were going to get harder, and this one's definitely harder. Well, it is B, so two people figured it out. I don't know who those two people were, but either one of you want to step up. Maybe I should have told you only one of you got it right. We're probably now each waiting for the other one to volunteer. Come on.
I can do it.
Great. Sorry, Peter.
Yes. So what I did was, so there's 30 coins in total. I just added 8 plus 10 plus 12. And then similar to the question before, because the question is phrased as at least one dime will be drawn in 3 draws. So I try to calculate the possibility of not drawing any dimes. And so what I did was, so for the first draw, the probability of not getting a dime would be 20 over 30, because that's the number of quarters and nickels over the total number of the coins. And then
Right. So what we want to do is draw. So we're going to do draw number one, and we want to get no dime. So the probability of getting that is we either get a quarter or a nickel out of the 30 total coins. So if we do
yes.
that, so far so good. We haven't drawn a dime. Then what happens?
And then you would do the same for the second draw, and then the third draw. It's just 8 plus 12 over 30, and then you multiply all that up.
Yeah, and importantly, it stays at 8 plus 12, or 20 over 30 for all 3 times, because they're saying that we put the coin, we draw a coin out, and then we look at it and we say, oh, we got a quarter, or we got a nickel, and then you put it back in. Okay. This would be a little bit harder if we had to adjust the probabilities for as we were taking a coin back, if we weren't putting the coin back in each time. But with this, it's a little bit more straightforward, so that the total number of coins stays at 30, and the total number of quarters and nickels and dimes all stay the same for each draw. So our chances for each draw is just 20 out of 30 that we won't get a dime, or 2 out of 3. Okay. And then, so what's the last step?
So I multiplied all that.
Yep.
And to make it easier, I just made it 2/3.
Right.
Times 2/3 times 3, or times 2/3, and then that would be
The third
8
power, right? So that's 8
over
over
27.
27. Okay, so that's the probability of no dimes, is 8 out of 27. So now what?
And then it's just 1 minus 8 over 27. So just 27 over 27 minus 8 over 27, which is 19 over 27.
All right, let's get the common denominator. All right, so 27 minus 8, 19, 19 out of 27. There you go. Okay. That make sense, guys? Definitely trickier. All right, you know what? Since we're just about wrapping up, let me show you the last one. So try that. All right, just in the interest of time, because yeah, we are supposed to wrap this up in a couple minutes. Guess. Just guess something. Does it seem likely or unlikely that this outcome will happen? I was hoping to do like a wisdom of crowds thing, just from guessing, but guessing. So, okay. So, any volunteers here, even if you didn't, get to an answer, but any approach? Here, let's close it there. Well, one person got it right. The answer is B. So I don't know if that was a guess or not, but sometimes you guessed right. Any observations about this, or do you want to walk through this? Here, let me just walk through it. Okay, so check this out. We got 21 total companies. We got 8 red, 7 blue, 6 green. You're going to choose 4 gumballs randomly. We're looking for the probability of getting 2 blues and 1 red. Exactly 1 red, which implies that the other one would have to be, right? Okay. The other thing is when they say like we're going to choose 4 randomly, but we have to think of this as like choosing 1 at a time. So on the last one where it was like you're choosing 1 and hopefully not getting a dime, putting the coins back, and then we're picking again. With this, we have to think of it in kind of a similar way, except we have to pick them 1 at a time. The only way to do it so that the math works is that we look at the probabilities of like, all right, I picked the first one. Like, my finger touched that gumball a split second before it touched the second gumball, a split second before it touched the third gumball, a split second before it touched the fourth gumball. So we have to look at them in 4 separate things, right? So, okay. The total number of ways to do this, or rather the probability. Let's just say we do it in this order. Let's say we do a blue and then a blue and then a red. Okay. So if we pick a blue, that's going to be 7 out of 21. Okay. And then we pick another blue. Now, we already picked one of the blues. So first of all, there's only 20 gumballs to pick from. And then since we already picked one of the blues, there's only 6 blues left to choose from. So the probability that our second gumball is also a blue is now 6 out of 20. Okay. Now we got to pick a red. There's only 19 gumballs left to choose from. Of those 19, 8 of them are red. Okay. And then we got to pick a green, and there are only 18 gumballs left, and 6 of them are green. Okay, so the probability of doing exactly this, blue, then red, then green, is this thing, 7 over 21 times 6 over 20 times 8 over 19 times 6 over 8. Okay. What haven't we accounted for yet is there's other orders in which this could happen. So this is where now, if we want to do the n factorial, r factorial thing, this is going to help us get the rest of the way. So I have 4 total letters, but 2 of them are the same. The 2 blues are the same. Okay. So this is 4 times 3 times 2 times 1 over 2 times 1. That cancels. That cancels. Okay. So that's 12. So basically, the answer here is going to be this times 12, because there's 12 different orders to put B, B, R, G in various orders. And so if we just multiply this now, let's see, so we would like cancel out, let's see here. So like 7 over 21 is 1/3. 6 over 20 is 3/10. Can't really reduce the 19. This is 1/3, and then this is times 12 over 1. So then I would do what else? So like 12 over 3 is 4. 3's cancel. 8 over 10 is 4 over 5. So what I'm left with is 1 times 4 times 1. So that's 16, 4 times 4, over 5 times 19, which is 95. So I'll leave you there. Again, the recording will be available. This is definitely a hard problem, but you see how it's just a bunch of, it's putting all the same pieces together, just with more layers. It's kind of a classic GMAT thing. So I'm going to stop the recording, but thanks for hanging out with me on a Friday evening. And again, sorry about the technical issues on Wednesday, but glad you guys made it out. And yeah, I have a class starting next week, next Tuesday. That's going to be a Tuesday, Friday course for like 10 weeks. And yeah, so hopefully I'll see some of you guys there, or maybe in a future course or a future session. So good luck, and hope everybody has a good weekend.